What's up, everybody? Today we have an amazing problem for you guys, man. We're gonna be talking about search and rotated sorted array, right? So this is gonna be a great one, guys. So let's quickly read the problem statement, right? So it says there's an integer array nums, right, sorted in ascending order with distinct values, right? So okay, very important. So we have a sorted array with distinct values, right? Okay, should be easy. It says prior to being passed to a function, right? Nums is possibly rotated at an unknown index. Okay, pretty much work. So this example makes sense, right? So this is how the regular sorted array look like, right? But before they pass it to us, right, they rotated, pretty much shifting the stuff around, right? Keeping the original like order, right? But it's been shifted. So now instead of the zero being there, the smallest element being at the beginning, right? It's been shifted somewhere, right? Which is shifting the whole array, right? Which makes the number to wrap around the array appearing. So once they go, uh, so the last number gets shifted by one, right? It goes on to the other side, it wraps around the array, right? So that's why it appears on the other side, right? That's how you see the seven here because it's been shifted many times, right? And then the zero zero right there, but it's been shifted all the way to this index, right there. Okay, so that's pretty much what they're saying. We're gonna be giving the array, but rotated, shifted. Gotta think about it like that. Okay, so now they want us to find right after the possible rotation, right? And we'll also be giving an integer target. They want us to return the target if it is nums, if it is in nums, right, or -1 if it's not in nums. So pretty much they will be given a target, right, along with the shifted array, right? And make sure I stress that enough so you guys understand what's going on, right? You want to find the target number, right? That's in the array, right? And you might be tempted to say, oh, it's just pretty piece of cake, right? Just look through the array, you find a target, you return it, right? It's linear time complexity, won't hurt nobody, but no, you have to implement it all of log n, right, which is important, which makes this problem a little bit interesting, right? To kind of use our brain a little bit, right? Yeah, important. So we already know log of n, you know what kind of algorithms or what kind of data structure you're gonna need to kind of achieve that time complexity that you want, right? So yeah, so let's see what they're talking about, right? So we have a 4, 5, okay, so this is an example, and then the target zero, and then we're looking for the target zero, right? So now, so we see the zeros at 0, 1, 2, 3, 4. It's at index 4, right? So that's how we're able to return 4, right? The way I'm doing it right now, I'm just the linear loop, right? That I mentioned earlier, right? We could have looped through and define zero, right? But that's not what we're gonna do, right? So we're just going through the examples right now. So and example two, right? Target three, but there's no number three here, right? So there's a little bit of a dilemma. So therefore, the target does not exist, right? We return -1, right? And then we have a nums one, target zero, -1, right? Because the number does not exist, right? So this is all the constraint that we're given. Okay, so very important, right? So it says num is in ascending order, right? So make sure, all right, that is possibly rotated. So nice. So now we got all the requirements ready, guys, right? So now it's kind of the time for us to come up with some kind of a plan to attack this, right? So in keeping the O of log n in mind, right, that they're saying to us, right? We need to keep that in mind, guys, right? So interesting. So how can we efficiently search, guys, right? But the numbers are shifted, right? How do I know how to search? What kind of algorithms are we? So we know that, they want log of n, right? We're gonna have to apply the binary search, right? Because it's the efficient search algorithm, right? To the for a particular element, right? So how do we apply binary search to this problem? We know it has to be binary search because log of n, right? So how can we achieve that, right? Hmm. So we're looking at all the numbers, right? So if only, how do we, so we know binary search deals with dividing in half, cutting down the search span in half at every iteration. How do we do that? How do we make that call? Okay. This, okay, so how do I know in which partition to continue searching, and which part to do? Hmm. About this, guys, right? So the we're gonna have to do this in a couple of steps, right? So the first step, right? Because this reminds me of another problem that we did, right? Once we then the other problem that we did involved finding the minimum number in a rotated array, right? We had to find that, right? So how this is going to help us in this particular problem, guys, right? It's going to help us by knowing in which partition, right, of the array we should search in, right? Instead of searching for the whole array, right? Uh, Once we find the minimum number, right, we'll be able to divide the array in half, right? Dividing it in half, allowing us to be able to search either on the left side of that minimum number or on its right side, right? So now we know that everything on its left is going to be sorted as well, right? In ascending order, right? And everything to its right will be sorted in ascending order as well, guys, right? Because, right, of the fact that the array is sorted, that's why we can be confident that this can work, guys, right? So the initial goal is to find that minimum number, right, guys, right? So how do we find that minimum number? That's kind of the thing that we're gonna do, right? So we're gonna check, right? So we're gonna apply binary search to find that number, right? Just like we did last time, guys, right? So for this particular example, let's go quickly do it real quick if we have enough time. Okay. All right. So to find that minimum number, right, what would we do, guys, right? We would pretty much apply binary search for the whole array, right? We start off by 7 being the middle element, right? And then once we check the middle element with the rightmost element, right, which is the last number in the array, right? We check, is that middle element, is it greater than the last element, right? So if that's the case, guys, right, we know that the minimum number exists on this side the of the array, right? You know what I'm saying? Yeah, because, guys, right? What I'm trying to say that so it exists on the right side because the number that's the least, right, will be the last one to wrap around the array, right? So if there still exists some numbers on the right side, right, that's smaller than the middle element, right? We know that the smaller number is going to exist in this partition, right? So that's why we do that, right? So once we're at 7, we say, oh, cool, there's numbers to my right that are smaller. So now the search space becomes here, right? So we do left is equal to mid plus 1, right? So now the partition's here, right? Okay. And then we do the same thing, right? We see the middle midpoint. We see is it's bigger than 2? No, it's not bigger than 2, right? So now the search space becomes 0, 0, and 1, right? And then we apply binary search, and then we find out that the 0 is the minimum number, right? And once we find that, right, we store that information, right, in some kind of rotated index, right? We could call it that, right? Rotated index equals 4, right? Okay, so once we got that now, right, we can know in which partition to continue searching, guys, right? Uh, so now we could say, all right, cool. We're gonna check. Does the minimum number, does the target number, right, exists from the rotated index to the end of the array, right? Does it exist in this partition? So this is where I should search, or should I go ahead and do it in this partition, right? Which is from the beginning of the array to the rotated index minus 1, guys, right? I want you guys to be aware of that, right? This is how we cut down search, right? So we're not gonna waste our time, right? If the number does not exist on the right side, we're not gonna waste our time searching on the right side, right? Right? Just like if we know that the number resides in this half, right? We're not gonna bother searching for on this half, right? So we discard of that, right? So we see how we apply 2 binary searches, guys, right? To so the first binary search to find the minimum number, so we could divide the array in half, right? That's the key concept that I want you guys to understand, right? So after we find that number, we divide it in half. We search in either this partition, the right partition or the left partition, right? Yeah, and then once we know the every both sides are sorted, right? So we apply binary search on whatever side that we decide to search on, you know, which is going to cost us another log of n, right? So that's kind of the main point, guys, right? So if you guys understood the thought process and the proposal I'm trying to say, right, let's quickly go ahead and implement it real quick. I think it'll make a lot more sense. And let me know in the comment section if you guys have any questions on this, right? So it'll be very, very helpful. If you guys could let me know, right? So what we're gonna do, guys, we're gonna start off with the left corner, right? Right, and we're gonna initialize. So we just initialize n equals to nums that length minus 1. So let me remove autocomplete. All right, and what we're gonna do right is go to the last number, right? So you see the initially notice how we do binary search, right? We consider the whole array, right? And then at every iteration, guys, we're gonna divide in half, right? So we're gonna apply modified binary search, guys, right? So while the left is less than the right pointer, right? We're gonna calculate the midpoint, right? Every iteration. We're gonna do this, guys, to avoid an overflow, right? So how we do in every problem, okay? And then what we're gonna do, guys, we're gonna do a couple check, just like we did in the other problem, guys. We're gonna check, does the num of mid, right? The middle element, is it greater than the number, the rightmost number, right? Which is, right? If that's the case, guys, right? The rightmost number, okay? So if that's the case, right, we're gonna continue searching on my like left, on the left of the midpoint, right? The 7, check, does 2, is it greater than 2? Oh yeah, cool. So the number is gonna be on my right side. I know that for a fact, right? Okay, because there are still numbers less than I am on my right side, right? So yeah, okay. Just make sure I stress that enough, guys. And if that's not the case, right, we update the we update the right pointer to be at mid, right? Because the midpoint itself can be the least, what I'm saying, the least, the minimum value. That's what I was trying to say. That's the word I'm looking for. Okay. So what we're gonna do, we're gonna store that information, guys, in a variable. All right. Just make sure space so you guys see everything that's going on. Okay. Okay. Rotated index. Okay. It's gonna be stored in the left corner, right? When we exit the loop, right? So after we do that, right, we're gonna reinitialize the variables left and the right corner, right, to equal to n minus one. Okay. So now we're gonna make this is the part where we're gonna decide in which part of the array. So now that we found the this example was given to you guys, right? Now that the we found the middle element, right? Now we're gonna decide, do we search on the left side or do we search on the right side, right? We're gonna do that by updating either the left variable or the right variable, right? This is what we're doing here, okay? Make sure you guys understand what I'm doing here, okay? So we're gonna do a check if, right? So we're gonna check, does the number reside on from the rotated index to the end of the array or from 0 to the rotated index minus 1 part of the array, right? So this is what we're doing, right? To search and reach partition. So we're going to check this, the target. Is it greater than or equal to the nums rotated index? And the target is less than or equal to nums of right n minus 1, right? The last number of the array, right? See what exactly what I'm doing here, guys, right? If that's the case, right, we know that it's on the right side, so we need to update our variable to be equal to the rotated index. Okay. Else, that's not the case, right? It's on my left side that we do the right pointer equals to rotated index minus 1, guys, right? So what I'm doing here. So this is this partition right there. Okay. So now if it's on the left side, right, it's gonna be from left equals 0 to the right index to the index minus 1, right? So hopefully you guys understand everything that I'm doing. Okay. And now we just apply another better search, right? Right now at this point, I would probably just, if I'm an interview, right, just use probably use built-in functions that your language have, right? Because you've already demonstrate that you can you understand the better search concept and you know how to apply it already, and you have applied it correctly. You should be in good shape. Okay. So now we're gonna look for that particular number, right? So another random search, guys. Left plus right minus left divided by 2. So now we're gonna do a check, guys. If zoomed in, so if the nums of mid, right, equals target, if that equals to target, guys, we return the midpoint, right, which contains the index of that target element, right? So yeah, and then if that's not the case, you can either do two checks, right, just like we do for other search problems. So we're gonna decide, should we cut down, remove the left half or the right half, right? So dividing it in half every step, guys, right? So we're gonna do a check. Now the mid is less than the target, right? If that's less than the target, right? Value of it is less than target, right? So I need to go to the right so I can find and get closer to the target as possible, right? See what I'm doing? All right. Now, if the mid is greater than the target, so I need to go lower, right? So I could find that, right? And then after that, guys, right? If we don't find anything, we're simply going to return a -1, right? Looks like we did everything correct, right? We've initialized the variables, right? We apply better search to find the minimum elements, right, in the array, so that we can divide the array in half, right? And so that we could know in which partition we should apply binary search, right? So either on the left side of the minimum element or the right side, right, including the element, right? Because both sides are sorted, right? So we're guaranteed we'll be good. We can apply binary search, right? Because I've already explained how it's sorted, right? Because the array is originally sorted and how the numbers are shifted, right? Not shuffled. Okay. Make sure that I understand that part. Okay, so we decide which part of the array. So if it's on the right side of the array, which is, the target is greater than or equal to the index, all right, or less, right? So I think we've had enough time. Let's press run code. All right, looks good so far. Let's press submit. Awesome, guys. We were able to pass all the test cases, guys. So if you guys found value and you guys understood the thought process that I'm trying to do in this question, guys, right? Let me know that in the comment section. Let me know what kind of problems you guys want me to do in the future. Really, really, really appreciate some feedback. And yeah, if you guys are new here, subscribe. Yeah, and I'll see you guys in the next video.